Right. So today we will see different concepts of ETL testing. First theoretical concept we will understand, and then we'll go for the practical session. Right. So first of all, what is ETL? What are the things we need to do as part of ETL testing? And then what are the different types of testing we have to conduct as part of ETL? Then what is the ETL testing process? And then we will go for the tools and so on, and how to write the ETL test cases, how we can execute, what are the different types of ETL defects or ETL bugs, how we need to report them. So these things we will discuss later. So first of all, for today's session, we'll purely concentrating on there are we need to learn ETL testing in different ways. So first thing is we need to know what to test, what to test as part of ETL testing, what to test, that we need to know first of all, and then we need to know how to test. This is the second part, what to test and how to test. So today we'll completely focus on what to test as part of ETL testing, and then what are all things required for testing. So that we will focus, and then in the next session I'll cover the how to test part. So whatever testings we have identified, what are the areas we have identified, then how we need to test them. So that is the second part. So how to test those things. Now today we will focus on what to test. So now here let me share my presentation, just a moment. Right. Now, first of all, let us understand what is ETL process. So ETL, as I said, ETL stands for extract, transform, load, extract, transform, and the load. There are three terms which are most important: extract, transform, and the load. Extract means we need to extract the data from different sources, and we need to apply certain rules on the data. That is basically part of transformation. And then once we apply the transformations, then we load the data into target database. That is basically data warehouse. So ETL stands for extract, transform, load, and it's a process of how data is loaded from the source system to the data warehouse, the end-to-end process called as a ETL testing process. Now let us see this example. So in this example, I have two tables. Extract, these are the two sources I have, and there are two tables. Table is same, but there are these two tables are from the different sources, right? So here the bill ID, date, and the name amount. So I have three different fields, and even the second table having the same data: bill ID, date, and the amount. Now this is basically sources. So from this we need to extract the data, and there is transformation. So what is transformation? If you combine this data and put it in the one table, so what is the order? It will come like 1 2 3 first records, and 10 5 and 17. So first three records are come from the first table, and amount is mentioned, and the 1 2 3 the second records 4 5 6, it becomes 4 5 6, and it come as a uh, date field. So if I observe here the sources table, the month is in the format of uh, text, October, November, right? When you come to the transformation part, we applied the date in the different format. So this format and all we need to take care as part of transformation. Okay, in the sources maybe the date format will be different, but after transformation, during transformation, we need to define the date in certain format. And once we transform, once we apply this transformation, then we need to apply the data, or we need to load the data into the target system. So this is the actual data which will be available in the target systems. Okay, so extraction, transformation, and then loading. So these are the three important stages we have, right? So now let us see. Usually we load the data in the two modes. One is called as a full load, or it is also called as a bulk load, and the second mode is incremental load, or it is also called as a refresh load. So data loading is always not done at the same time. We will do multiple times. Okay, so full load means the data loading process. When we do it very first time, it can be referred as a bulk load or fresh load. So for example, data warehouse completely empty, there is no data at all. Now first time we will load the data, full data. So for example, let me show you with the diagram. Just a moment. So here we have source systems. So this is the source 1 and this is the source 2 and this is the source 3. So we will get all the data in the staging area first. This is a staging area. So here actual data will be available. So on this data, we will apply some transformation rules and then we load the data into data warehouse. This is exactly data warehouse. So once the transformation is done, then only we need to enter the data in the data warehouse. So this staging data, the complete data, if I load everything in the data warehouse the first time, for example, let us say there are 10,000 records are there. Now, if you first time when you load 10,000 records in the data warehouse, this is basically called as a full load. Full load means we don't have any records present in the staging server. So all the records are loaded into data warehouse. This is basically called full load or bulk load. And for example, after 10 records are loaded, then in another session, for example, we got the few more records. Like now this is becomes 10,500 now. So few more 500 records are added. So in this case, we don't again add these 10,000 records because these data is already present in the data warehouse. We don't add again. So if there is any updates, for example, in these 10,000 records, if there are some modifications or changes happens, only we will update those records. But we don't load complete data. But whatever the new records are added, only those records we will load into the data warehouse. So every time, every cycle, we will load only the new records always. This is basically called as incremental loading. Incremental loading or called as a fresh loading. Incremental loading or fresh loading. So every time, but whatever data first time we are loading into the data warehouse, that is basically called as a full load. Those records we won't touch again and again until those records are modified. Okay, so this is the context of full load and incremental load. Full load is also called as bulk load and incremental load is also called as a refresh load. Okay, now data cleansing or data scrubbing. So these are all important terms in terms of ETL testing. So data cleansing and data scrubbing. So what is data cleansing? So data cleansing means sometimes whenever we load the data into the target systems, there will be some irrelevant data. Irrelevant data means which cannot be useful. Okay, and sometimes duplicate data or incorrect data or incomplete data. There are many types of data will be there, right? Basically, ultimately the data is irrelevant data. So we need to make sure that data should not be part of the data warehouse because this will occupy a lot of memory things, right? So the data cleansing means it is a process of removing irrelevant and redundant data and correcting the incorrect and incomplete data. So this process includes two things. One is we need to remove irrelevant data and redundant data. That's the first thing. Suppose if there is a data is incorrect, we need to correct the data. We need to correct the data. How it is possible? While uploading, it is possible. Updating. So first time we already updated the data in the data warehouse. There is some records, but in future some record is changed or some values are changed in the source system. Again, those records are loaded, and then what happens? Update will happen, right? So what is happening in the update exactly? Whatever the records are incorrect or old records, so that will be updated. That means we are indirectly correcting the incorrect records. So that is also that process is also part of data cleansing. So data cleansing means the data cleansing is a process of removing irrelevant and redundant data and correcting the incorrect and incomplete data. It is also called as data cleansing and data scrubbing. Data scrubbing, data cleansing or data scrubbing. Okay, remember these terms, very important. Data cleansing means just say cleansing the data, irrelevant data. It is a basically cleaning. Okay. Now, data masking. What is data masking? So when you observe in the real time or if you're working on some real time applications, some sensitive columns, for example, or SSN field or credit card numbers, those numbers you cannot see complete value, right? Sometimes first two to three values they will display and remaining star will be stars, right? That is basically called as a masking the data. They will hide the exact original data, but the user, they will display for the user, they display the some irrelevant, some duplicate of some different kind of, some wrong kind of value they will display. That is basically called as data masking. So this is becomes a very big, very important feature nowadays, because whenever the data is growing, the security also very much important, right? So wherever the sensitive fields or sensitive data is available in the data warehouse, we need to apply certain masking techniques to store the data. Okay, but in the database side, we have two types of masking. One is persistent masking, another one is dynamic data masking. Persistent masking and dynamic data masking. So what is persistent data masking means? For example, if you have a data warehouse, let me show you. First of all, data masking is nothing but hiding the original values and showing the invalid or wrong values to the user, incorrect data to the user. That is basically called as data masking. And under data masking, we have two things: persistent data masking, and there is dynamic data masking. Persistent data masking and dynamic data masking. Persistent means, for example, here I have a source 1, source 2, source 3, right? I am getting the all the data in the staging server. First I am getting everything in the staging server. This contains the original data. Now here I have a data warehouse. On here I will apply some transformations, and then I load the data in the data warehouse. And from this data warehouse, people will use some reporting tools and they will pull the different kinds of reports. They will use Picker or Tableau, Talent. There are many BI tools are available in the market currently. So by using those tools, they will report the basically reports. They will generate the reports. Now, who will generate the reports? The users, right? For analytical purpose. So here there are two ways. Persistent data masking means whenever we loading the data from the staging to data warehouse, during transformation, we will apply the some masking techniques on the data. Okay, we'll apply some masking techniques on the data. Then the target data will be masked data. Here we will get only the masked data, but data will be available, but the sensitive fields will be masked. Or if it is SSN number, first letters 2 or 3 letters will be displayed and rest of them will be masked like stars. Similarly, credit card number or sometimes telephone number, so all kinds of sensitive fields we will masked. So if we mask the data in the data warehouse itself, in the tables itself, that is basically called as persistent data masking. And there is a concept called dynamic data masking. Dynamic data masking means in the staging and data warehouse, in the both the places we have a original data, but when you pull the report from this particular data, when a user is interacting with this data warehouse, here we will mask the data on the fly. This is dynamic data masking. So here we are not masking the exact data on the database. We are masking the data which is pulled by the user at the runtime on the fly. Okay. So for that we need to use dynamic data masking. So for this persistent masking, dynamic data masking, there are n number of tools available in the market. Okay. So Informatica tools are available, IBM tools are available, Oracle tools are available. So those tools will apply the data masking kind of stuff. Okay. So we can do the data masking in two different areas. One is at the time of transformation, we can mask the data and store them into the data warehouse. That's the one thing. This is persistent data masking. So original data also it is masked. But here, when you pull this report, when a user is accessing, suppose some users are admin users, some users are normal users. But admin users should be able to see the original data, right? But the normal user not required to show all the sensitive field. So based upon their privileges, they can see the data, or it may be masked data or original data. That is again applied. That is again depending on masking rules. So this is basically called as masking, data masking. So this is very important at the time of doing the ETL part. Okay, when you do the transaction, when you do the transformation, this time you can apply the data masking, and also at the time of pulling the reports, there also we can apply the data masking. But if I apply the data masking at the time of generating the reports, that is not exactly 100% masking. That is not masking original data. That is masking the data on the fly. Okay. So this is basically concept of data masking, masking the data. Now, organizations never want to disclose highly confidential information into all the users. That is a basic. Yes. Are we going to check the data masking? Means we are not going to check any data masking, but only thing is appropriate sensitive fields are masked or not. That we need to verify. So as per the document, for example, there is a SSN field as there. So that should be masked. That is as per the requirement in the data warehouse, SSN field should be masked. So what we need to verify as part of ETL testing, whether that field is masking data is available or not. It should not show the original data. So that we are going to validate. Okay, but internally what kind of masking techniques they have applied, that we are not going to check. Okay, that is again part of the admin team. Whoever is doing whoever is applying those logics internally by using data masking tools, they will take care of that. But only our job is whether the data is applied as a the data is stored in the data warehouse is masked or not, that we need to verify. Okay. Next, so here that organizations never want to disclose highly confidential information into all the users. This is the main purpose of data masking technique is implementation. Okay, so the process of masking, hiding, encrypting the sensitive data is called data masking. So here there are three things. Masking. Masking means first three letters will be displayed, rest of them will be stars, or first all 5 to 6 letters will be stars and last 2 to 3 letters will be displayed. That is basically called as a masking. Sometimes hiding will be happen. Hiding means in the same column, for example, instead of the credit number, it will not, there is no value at all. Suppose they will give some nulls or they will give some zeros, but you cannot even see the data, completely hiding the data. Encryption. Encryption means there is some understandable code will be there. For example, there is a 1234, that is a number we can understand, right? Instead of 1234, they will provide some special kind of symbols, encrypted format. Instead of 1234, they will maintain some encrypted code. The code will be automatically generated, encrypted code. There are some tools. So by using those tools, they will encrypt the data and provide the encrypted data in the fields. That is basically called as encryption data. So why we need to require for this? Because of security. As much as data is growing, security is also plays important role. Nowadays, big data, right? So data is growing. So as apart from this, we need to also upgrade the different kinds of security techniques. So most of the companies are focusing on security part. Whenever the data is growing, the security testing and security areas also growing. That's most important thing. So the data masking is a kind of a technique to secure the data at the time of loading at the and also at the time of projecting the data or presenting the data to the users, to the end users or customers. So there are the two areas where the data masking comes into the picture. So for example, here I have given few techniques here. So for example, replacing the subset of data. For example, here I have some data in a field. I want to replace with some other characters. Let us say AAA. So these are the characters. But exact value will be different, but I'm just displaying replacing the value with some value. Or we can replace the data with some dummy numbers. Or sometimes we can provide the data as a random numbers. For example, the credit card number is 1234. I'll provide like 2415 like that. So the randomly generated number I will provide. But as per the user, he feels this is the original data, but actually that is not original data. Okay, because I have given some random numbers. And then replacing the subset of data with dummy special characters. Sometimes we will provide some special characters instead of original data. And sometimes we will shuffling the characters or numbers. Shuffling means, for example, 1234 is there, 4231 or 3124. So this is basically called as a shuffling. So these are the few techniques we can use it at the time of applying the masking. But these are just manual techniques we can use, but there are lot many masking techniques are available. People will use those techniques to whenever they do apply the masking. Okay. Now let us understand the process now. So far we discussed three things. One is types of load and what is data cleansing and data masking. Okay, load means full load and incremental load. If I load the data full at a time, that is full load, and in future if I load the partial data upon incrementation, that is called basically incremental load. Data cleansing means we need to remove the unnecessary data or relevant data or redundant data or incomplete data. So that is basically data cleansing. Data masking means we need to apply certain masking methods or masking functions on the sensitive columns and then project the data to the user. So that is basically called as data masking. Then let us move on to the ETL process. What is process? Where it will start? So we need to understand different stages and different terms here. Here, observe this one. It includes ETL as well as business intelligence process. So the entire thing is called as a data warehouse. Data warehouse is nothing but ETL plus business intelligence. The combination of ETL as business intelligence. The combinedly we can call as a data warehouse. Okay. So now let us see ETL part where it will start. So the data sources can be anything. So for example, enterprise applications or customer relation management application. There are n number of applications will be running at the sources. So basically, they are maintaining the transactional data on day-to-day basis. In the last session, we discussed right OLAP, OLTP. Right? What is OLTP? Online transaction processing. OLEP means online application processing. Right? So online transaction processing means the sources. These sources are keep on updating on day-to-day basis. That is basically OLTP systems. But in the data warehouse, the data will be preset, that is basically called as OLAP, online application processing. The data will be used for analytical purpose. Analytical purpose. But the data will be updated during a time period, not on day-to-day basis. Okay. Now here the source data can be CRM or enterprise application. Sometimes it can be CSV files or flat files, and sometimes it is unstructured data. Sometimes the data will be like what is unstructured data? Any idea? What is structured data or unstructured data? This is very important to know. Structured data, unstructured data. So structured data means basically our text, numbers, these are all basically called as structured data. So if I say the database table, we will have the names, first name, last name, salaries, all same details, right? So whatever the values we are able to store in the tables, they are basically called as structured data. That data we can easily read it. When you come to the unstructured data, images is also a data, but that is unstructured. Voice is also unstructured data. Video files, audio files, right? Wave files and PDF files, text files, CSV files. These are all unstructured data. We cannot maintain the data in the form of tables. So to maintain that particular data, we have a different mechanism like Hadoop and big data and so on. But normal classical databases, we cannot maintain that particular data. But somehow we can store, but like image files, right? We can store them by using blob columns, clob, okay, so ilob. There are some data types are there in the database side. So by if I define a column with that particular data type, we can store the image files and XML files and so on. But somehow at some level we can manage the unstructured data. But at the complex files like videos or audio files, a big kind of image files, that kind of files, those kind of files we cannot maintain in the normal traditional databases. So the sources can be anything. It can be structured data or unstructured data. So the data can be before loading entire data into the staging area in the ODS. OD means operational data source. So what is ODS? Operational data source means this is another layer between source and staging area. So what is ODS will do? Operational data source. It is a database which has integrated data from different business or sources with different rules. So it gets the data from the transactional database directly. It will have a limited period of history data, hardly 30 to 90 days of data. So here operational data system means it seems like a staging, but it is not 100% staging area. Okay, so this operational database is having the integrated data, but the data keep on updating every 30 to 90 days. From this operational data source, we will pull the data again and put the data into the stage. Stage is also have a database. And in the staging to warehouse, between these two, we will apply the ETL process. Okay, but here in ODS to staging process, here we don't apply any transformations. Rules we haven't applied anything. ODS is a temporary place or buffer area where we need to put all the data in one place, that is operational data source. So once we ready with this data, and now again this is the temporary again, okay, we will pull the data from the ODS to staging area, and here in the staging area on this particular data we will apply the transformations, and between the staging and the data warehouse, between these two the transformation rules can be applied. Okay, so before when you do the ETL testing part, usually, so this part will be taken care by the administrator most of the times. So ETL developers or ETL tester will not be available here, will not involve here, because here we are not going to enforce any rules or any transformation. This is just dumping the all the sources data into one database. This is just dumping of data. So once the data is ready in the operational data source, we will get the data in the stage. So on the stage, exact data will be ready. So on this particular stage data, we will apply the transformation rules and then pull those records into data warehouse. So this is the end part. So till this is the basically ETL part. Okay. So ODS purpose means sometimes we will maintain the ODS. If it is a big kind of companies or large use kind of data, they will maintain the another layer. This is just additional layer. Sometimes if it is a small databases or small medium kind of companies, directly they will pull the sources data and put that into the staging area. That's it. So this is optional, but if it is a bigger companies and suppose they don't want to move the data from sources to stage directly, then in between they will put some other layer. Okay, that is basically operational data sources. Operational data sources means in this data we need to operate, pulling the data into the stage, then we need to apply the transformations and then pull to the data warehouse. Okay, so not only one ODS, there may be number of ODS sometimes. Maybe here I mentioned only one ODS. Sometimes we have two or three ODS depending on the data and complexity. Okay, this is just another layer we have. There we maintain the data, right? Right. So now next. This is the process based. Now let us understand each and every component. So far we understood the sources, ODS, stage and the data warehouse. Now what is this data mart? Data mart is also very important. So for example, in the data warehouse, let us say some data will be present. For example, a storing data. Suppose a shopping mall. A shopping mall having a different departments, right? For example, sales and products and employees, or for example, some other department. There are n number of department or transaction data, how many customers are coming. So these kind of data will be there. So based upon the data type means based upon the data criteria, they will divide the data. So for example, customer data is one part. How many customers are coming into the store? That data is one part. And how many products are buying per day? Okay, so how many transactions are happening per day? That is basically transactional database, right? So then how many products are coming inside to the store, new products? So that is another data. So based upon the data type or criteria, they will divide into different parts. Okay, so those parts are called basically the data mart. So data mart means a categorization, basically a category, same categorize of the data, same category data will put together in one place. That is basically the data mart. And then suppose I want to find the report. For example, I need some report. So what does the report contains? From the last 1 year, what are all the products are purchased well? Okay, according to the store, I want to check from the last year, how many products, I have 100 products, but how many products are people purchased well. So that I want to get. So this kind of information or this kind of data will be available under some database or some few tables, right? Not on all the tables. So I need to categorize those tables in one section. That is basically called data mart. And similarly, I want to verify, I want to get some report like how many new products we introduce in my store per year. In this particular year, how many new products I have introduced. So that kind of data will be available under product database. That is a different category of data. So that will be pulled in the separate mart. That is basically these are categories. Okay, these are the different sections. So each and every section of data or each and every similar kind of data we call as a data mart. So now finally these reports will be generated based upon the data mart. So data mart is also a kind of database. Data mart is also a kind of a database. So from these data marts, by using reports, here what are the reporting tools will come like Tableau, Picker or Talent, right? Like business objects, Oracle business object or SAP business object, Cognos. So these are all the different business intelligence tools available in the market currently. So what those tools will do? Those tools will generate the reports or dashboards or picture or in the graphical format. So by seeing those reports or by seeing those graphs, then they can understand the business, how business is growing. Okay, what are all profits, what are the losses. So this kind of information they will use it for analysis purpose. So that analysis will be used for growing the business. That is all part of the business intelligent part. So here the business intelligence tool will come into the picture. So end users are nothing but those are the users who are pulling these reports. So by seeing reports, they will do the some analysis process, analytics part. So here data analytics part come into the picture. So this is an end-to-end process, end-to-end ETL process, right? Now let us see. ODS means we already discussed. It is a database which has integrated data from different business or sources with different rules. And it gets data from the transactional database directly, and it will have a limited period of history data, hardly 30 to 90 days of data. After completion of 30 to 90 days, the data will be removed and the fresh data will be loaded into ODS. Again, we need to pass the data or transform the data to the data warehouse, right? So this is all about the ODS. Next, staging area, just we discussed. A staging area or landing zone is an intermediate storage area used for data processing during extract, transform and the load. So here this is exact area where we need to apply all our transaction transformation rules on the data. Okay, nice. Warehouse. The warehouse is the target system. So the data warehouse, also known as enterprise data warehouse, EDW, is a system used for reporting and data analytics. As I said earlier, this data is why we need to get this data, because we need to do some kind of analysis for business growth. So is a system used for reporting and data analysis and is considered a core component of business intelligence. This is a base for the business intelligence tool. If we want to work with the business intelligence tools, we require the data in the data warehouse. And data warehouse are central repositories of integrated data from one or more disparate sources. Okay, so this is all about the data warehouse. Next, what is data mart? The data mart is a subset of the data warehouse and is usually oriented to a specific business line or a team. So what is that? What does that mean? I'm saying here data mart is a subset of the data. As I said, we have different kinds of data in the data warehouse. But if you want to pull the records on specific department or specific area, we need to get the subset of them. So that's the reason we are using this word called subset. So the data mart is a subset of the data warehouse and is usually oriented to a specific business line or a team. That is basically called as data mart. right? So far what we discussed is the ETL process, end to end process. This is high level understanding. Now we will see few more terms. Data retention. So when you do the ETL testing part, okay, we need to apply some data retention part, archiving and purging. So basically this will applicable after completion of ETL process. So when you come here in the data warehouse, we need to maintain the data. We need to maintain the data in the warehouse, right? Suppose if you have some transaction, or if you have an account in the bank. Suppose let us assume you have an account in the bank. So anyway, every month you will get some monthly transactions report, right? And suppose some one day you need a report, or you need some for payslip, for some reason you need some bank statement from last 5 years or from the last 10 years. Where that data will be present? That data is not present in the ODS or transactional systems. If you want to get the history of data, that data should be pulled by the data warehouse. That data will be pulled from the data warehouse because that is historical data. Okay, sometimes what happens is, suppose after 5 years or after 10 years, you remove your account or you have disconnected that account. So how many years they will maintain your account? Once you have disconnected or once you have closed that account, the bank is not required your account, right? So there is having some limited date. So till that particular date or till that particular year, they will maintain the data, your historical data. Maybe that is 6 months or maybe 1 year. After that, your data will completely lost. So what is that process is basically called as data purging process. Data archiving, data purging. There are two things actually. So what is archiving and purging? There are two things. This is basically called data retention. Retention is basically nothing but we need to uh, remove the unnecessary data after few many years. Okay, that is basically called data retention. This retention is happening in the two different ways. One is archiving, the second one is purging. Archiving and purging. So the data retention is having two different cases, archiving and purging. Archiving means, here I have mentioned one example. The data retention means defining how long the data need to be available in your database. That is basically data retention. So every organization there is some criteria how long the historical data should be maintained. So that is basically called as data retention. So data retention means defining how long the data need to be available on the database. That is data retention. Then why data retention policy is required? What is the necessity? Because of three reasons. One is performance will be impacted due to increasing of data. So if they maintain historical data like 20 years, 30 years, 40 years, but that is no useful, right? So performance will be automatically impact. If the data is increased, parallelly the performance automatically reduced. That's the one problem. Because of that reason, the data retention came into the picture. The second thing is the cost will be very high for database accumulate the data. So usually if the data is increasing the database, we need to maintain the data storage also, right? So storage also costs much. So this is another problem. And the old recorded may not be useful for end user over certain period of the time. So because of these three reasons, we do or we apply data retention techniques. So the data retention is basically we need to define how long we need to maintain the data in the data warehouse. That is basically called as data retention. And here in the data retention, we have two things: archiving, purging. So let us see what is archiving and purging. But the intention of archiving and purging is same. Maintaining the data in data warehouse. How long we need to maintain the data. What is purging? It means deleting the data from a database which crosses the defined retention time. Here in the purging, we'll completely remove the data nowhere available. So that is basically purging. So after completion of certain period of time, the data will be completely removed from the data warehouse. That is basically called as a purging. But when you come to the archiving, we don't remove the data here. Archiving means moving the data which crosses the defined retention time to another database. That is basically archiving. What archiving we will do is, here we don't remove the data, we will move the data in some other resource. Okay, from the data warehouse we will remove the data to the from other resource. So that is basically called as uh, archiving, purging and archiving. So purging means we completely remove the data from the database. uh, Once we reach the appropriate time limit or definite time retention time. And archiving means we'll move the data from one source to another some other databases, and there also we have time limit. Okay, once the time limit is reached, from there also we need to purge the data. So this is the basic difference between data purging and data archiving. This is a part of business intelligence. Okay, we don't bother about this much, but at least we should know these terms. Yes, it is a part of OLAP. It is a part of OLAP, Online Transaction Processing System, because the historical data will be maintained in the OLAP systems only, data warehouses only, right? So usually the normal transactional system, we don't maintain the historical data. So that's the reason the purging and archiving will be applicable only for OLAP systems. Now, which one we need to use? Which one we need to select? Archiving or purchasing? So this is again based upon the, yes, anyway we are using STDS, that is already there. But still, even though if you use that, after few months or after few years or 10, 15, 20 years, the data will not be useful. Maybe those customers will not be available and the user don't require that particular data. So in that case, there is no use of maintaining the data in our servers, right? Because of performance will be reduced. And the other thing is we need to pay some money to store the data in our records. So because of those reasons, we remove the data. We will archive the data or we purge the data from the data warehouse. SEDS comes part of ETL, not here. So when we transform the data from the transaction system to the data warehouse, like OLTP to OLAP systems, there we will apply the SCDs. Okay, that will not come here. Okay, so now what to select, archiving or purchasing? So here this is a criteria. If the old records won't be required at any point of time, then purchasing will be applied. Purging will be applied. When the purging will be applied, if I don't want those records in future, that's not at all required. In that particular case, purging will be applied. And sometimes maybe in future the data is required. There is a chance the data is required in future. So in that case, they will apply the archive methodology. Archive means just they pull the data or they move the data from database or to some other database, but they keep the data. So for doing this purging and archiving, there are n number of tools available in the market. Informatica tools are there, IBM tools, Oracle tools. There are many number of tools are available. So each and every purpose have been achieved by using those tools. Okay, but we need to understand as a theoretically what is that, how we need to do that. Okay, we don't need to go deeper into that, but that's not part of ETL, but still we need to understand this before going to ETL testing part. Okay, now let us see example for purging and archiving. What is the exact scenario? What is the exact use case for them? So let us see here. I have mentioned one example. There is a retail shop which maintains the data warehouse where all the sales data will be loaded at the month level. As business is growing day by day, still more data will be getting loaded. So now there is a store. The store is managing the data warehouse. The data warehouse contains the data at the monthly wise. Every month, how much data is loaded. So that data will be available for every month, monthly wise data. Now what happens is, after few many years, the shop has been running for the past 10 years. Now the data warehouse database size has got increased tremendously after 10 years, because we are storing the monthly wise data. So that's the reason after 10 years the database completely increased, data is increased. Then shop management says they don't want to view the report at month level for 10 years old data. That is their requirement. Until now, they don't have this requirement. They need data at the monthly level. But after 10 years, they don't want to see the data monthly level. But still they want to see the data at the year level. Yearly data, not monthly level, monthly wise data. There is a difference, right? Monthly wise data, yearly wise data. But after 10 years, they don't want to see the monthly level data. They want to see the data at the year level. So hence they are planning to remove the data older than 10 years. What kind of data? Monthly level data they want to remove, but still yearly data should be present. So at that time they want to keep the data at year level instead of month level. So the requirement would be roll up all months data into year level for data older than 10 years and delete the month level data. So this is basically data purging. Okay, purging means we remove the data completely. Nowhere the data monthly level data is not available here. But if we move the data in some other place or some other database, that is basically called as data archiving. Got it? Fine. So now let us move on to ETL testing life cycle or process. So this is very critical for us. This is most important as a ETL tester. So we are slowly moving into the practical session. So before entering into the practical session, we need to know where we need to start ETL testing, what kind of requirements we should have, and how we need to do the planning, what is the design documents we required, so what is input, what are input documents we required. So these kind of things we need to require. Like normally if you go for functional testing, we talk about requirement specification document, then we'll write test cases, test scenario, traceability matrix, right? So similarly for ETL testing process, we have the same process. Okay, but here there is different kinds of documents. So instead of function requirement document, here we have a mapping document. Okay, fine. So now let us discuss about ETL testing life cycle or process. Now ETL testing is go through different phases, starting from requirement analysis, test planning, test design, execution, defect reporting and retesting, and finally we close the test. So these are the different phases we need to go through as part of ETL testing. Let us go one by one. As part of requirement analysis, what we are going to do. What are the requirements we should have? Before going to ETL testing, what are the requirements we should have by hand? The major inputs for the ETL testing team would be two things. One is data model, the second is mapping document. These are the two inputs we require at the time of requirement analysis. First of all, we need to know about the data model, what kind of data model it is, and the mapping document. So what this document contains, I will show you these documents. Okay, I have these document templates. I will show you what is data model, what it contains, what is mapping document, and what is contains. I will show you in a few minutes. So data model basically describes the data warehouse. So data warehouse means again, what are all the data tables are available, what are the tables are available, what kind of data it contains, and what are the relationship between those tables. That is basically called as a data model. When I see the data model picture, we understand how many tables are there, what kind of data the tables contain, and what are the relationship between those tables. So that information I will get. And here we need to know two things: source as well as target. The data model from the source and also data model from the target. Both the data models I should have, because we need to verify, right, from the source to target mapping. We need to verify. For example, in the source table there is employee ID column is defined as a number field. In the same, in the target table also the employee should be as a number field. It should not be varchar or some other data type. So how we will know the data type and column names and everything? By seeing the data model. So that much is important. Data model is very much important to understanding the what kind of data it is storing, what kind of tables are there. Not only tables, sometimes there is views, indexes, synonyms. There are so many database objects will be there. So that is basically called as data model. The next important document is mapping document. This is a basically heart of the ETL testing. Mapping document. So this document clearly describes what are the sources, what are the targets. When we moving the data from the source to target, what are all the different transformation techniques we have to apply. That information will be there on the mapping document. There are two roles here, ETL developer, ETL tester. For these roles or these two people, mapping document is very much required. So based on the mapping document, the developer will implement the ETL scripts. Developer will develop the ETL scripts for seeing by seeing mapping document. Similarly, parallelly, tester will define the test cases based on the mapping document. Tester will define the test cases based on the mapping document. But who will create the who will develop the mapping script? Who will run the mapping scripts? Developer will design the mapping scripts and developer will run those mapping scripts. Okay. Then once the developers run the mapping scripts, they will inform to the testers. Okay, we have executed the ETL scripts. Then please go and check the data warehouse. Then what as a tester, what we need to do is with respect to the mapping document, we will have test cases, ETL test cases, then we will execute each and every test case against the data warehouse. So while writing your ETL test cases, two things are very much required. One is data model, because we need to also do the schema testing and so on. There are many kinds of testings we have to do. I will discuss in few minutes. Okay, so there are lot many types of testings we are going to conduct as a ETL tester. So for that we require two documents. One is data model, the other one is mapping document. Okay, most of the times these documents can be in the Word format or these documents can be in the Excel formats most of the times. Okay, so this is we should have these documents at the time of requirement, right? The next phase is test planning. So here there is not much difference between normal in function test plan and here ETL test plan. In the normal function testing, what is test plan? We will identify different scenarios we will put together and what is the scope of testing, what to test, what not to test, what kind of environment we need to use, how many people should involve in the testing. So how much time we need to take for sanity, how much time we need to take for regression and retesting. So this kind of information we put together, that is basically called as test plan document. So similarly, in ETL also we prepare the test plan document normally. So basically the test plan describes the how to test, what to test, when to test. These are the three important things we need to focus while doing the test planning. What to test, when to test, how to test. So these are the three things we need to specify in the test planning document. Okay, fine. So are you guys following? Kavita? Fine. Now let us move on to the test design document. Test design. So it is not a document basically. So here as a ETL tester, what we need to do is we need to prepare our test cases along with we need to prepare our test cases based upon the mapping document. So mapping document basically contains what are all the sources tables, what are all the target tables, and when the data is movement is happening between the source and target, what are the rules, transformation rules which we need to apply. So that information will be contained in the test mapping document. So based on the mapping document, we need to write our test cases. We need to write our test cases. That is all part of test design. And then mapping document is also we have a data model document. So that is also required. And then test execution. So once we are ready with the test cases, developer will execute the ETL scripts. Maybe they will use tools or they may use manual, but most of the times they will use tools like Informatica or IBM data stage. So they are ETL tools. So by using those tools, they will implement the ETL scripts. But how they will design the ETL scripts? By seeing mapping document. By seeing mapping document, they will design ETL scripts. So as soon as they want to move the data, they will run those ETL scripts, and the data movement happens completed. Then they will inform to the testers, like we have executed ETL jobs. People, they are called basically ETL jobs, not scripts. So we have executed our ETL jobs, then you have to verify them. So then our execution will be starting. So once we executing execution is whenever we start executing our test cases, then if you find any defects, as usual, we need to report to the developers. So what kind of defects we need to get in the ETL testing, that we will discuss in few minutes. Okay, what kind these are not functional defects. Basically in the functional testing, defects are different, ETL testing defects are different. Okay, and finally, once we completed everything, or once we completed all our test cases, there are no zero bugs, then we will sign off our testing. So these are the basic high level process: requirement analysis, test planning, test design, test execution, defect reporting and retesting, then test closure and sign off. This is the ETL testing process. So what are input documents we required? Two documents. One is data model, the other one is ETL mapping document. Right? Now, so is it clear everything so far? Kavita and Sandeep? Now, let us move on to the ETL test scenarios. So as a ETL testers, we need to focus what to test. What to test. So for what we discussed is the high level process. What is ETL testing? As a ETL tester, where I need to start, what are the documents I require, and different terminologies used during ETL testing part. So that we have seen so far. Now we are slowly entering into the what to test, how to test. So ETL test scenario. Basically, what is test scenario? Scenario means the area which we need to test it with respect to the requirement. So basically, as a ETL tester, we need to focus on different areas. So those areas basically called as test scenarios. Okay. So what are the different test scenarios which we are going to test as part of ETL testing? So the first, there are n number of scenarios. I have listed out each and everything. I'll go through this. Table structure validation or verification. Table structure verification. So here few testings uh, similar to just like a database testing, but the context is different. So for example, table structure verification. If it is a database tester, what he will test? Table structure verification means he will test the schema, like what are columns fields have defined, what is the data type of that field, right? That will be what is the length of each and every column. So that will be focused. But here as an ETL tester, we have, because of we have a source and target, both the source and target, we have two data models, right? And before testing the data, before validating the data in the data warehouse, the first of all we need to verify the schema. Schema means what are all tables available, what are those columns, what are our relationships, what are the constraints they have created. So these kind of testings we have to conduct. So this information is basically available under data model document. So data, the table structure verification. Table structure verification means the column name, data type, and the data length of a target table will be verified against the requirement. Requirement means again we need to refer the data model. We need to define. We need to refer the data model. That is most important thing. So that is table structure verification. So for each and every scenario, we need to write a test cases. Okay, we will see that how to write test cases and all. We will see in few minutes. So these are the high level scenarios which we need to focus on. Table structure verification, and then constraints check. We need to also check the constraints. Ensure that all required constraints are available or not. That we need to verify. Index check. So ensure the index created with the required columns. So basically index I haven't covered in the SQL part. So I'll cover this part later. Index is basically created on the tables to increase the performance. Okay, if data is huge. So for example, if I say you have a book, your book is having around 1,000 pages and different chapters are available. Now why we need to maintain the index at the first page? Suppose if you want to directly jump into particular chapter or particular page, you need to know that you will refer the index part. So in index you can see which chapter is available under which page. So that because of that, speed will be increased. Basically you can directly jump into the page and you can see the chapter. Similarly, in the database, if the data is growing or if data is very huge, they will create indexes on table columns. So every table maintains certain indexes. So those indexes we need to verify. So whether indexes are created or not, that information we need to verify. And source data validation. Source data validation. So constraints, index, table structure, these are all comes part of data model. We will get this information from the data model. Source data validation, data count check, this information available under mapping document. Okay, so now source data validation. So record the source table count and ensure that there will not be any junk or bad data exist. Source data validation. Source data validation means source tables also we need to validate. So whenever you do the ETL testing, we should have both source as well as target databases. Okay, so before testing the target, we need to check for the source tables, what data it contains. That is basically source data validation. We need to also write few test cases for source data validation. Then data count check. For example, in the source, I have 5,000 records. After ETL is done, in the target table also, I should check the count. How many number of rows should be there? The count should be equal and it should not have any duplicate records and it should not have any junk data, right? So we need to make sure or we need to focus on the data count after completion of ETL process. That is also we need to verify as part of ETL testing. Then data comparison check. So here ensure that source data was moved correctly to the target table by comparing data. So here data comparison means source table some record is there and the target table the data is already moved. We need to check whether the data is equal or not. And sometimes there will be some transformation will be applied. For example, in the source table, there is a salary column. In the salary column, there is a first row or credit card number column is there. So in the source table and the credit card column is there. In the first record, there is some credit card number. And after moving that column into target table, the credit card number appears as a shuffle number or some random digit number. So what kind of transformation rule applied between these two? There should be some masking rule applied. That is transformation rule applied. So we need to we need to compare the source data and as well as target data with respect to transformation. There is no guarantee the data should be the same. Sometimes the data should not be the same. If we apply the transformation on the source data, automatically the data will be changed. But according to the requirement, that should be. Okay, we should not say that is wrong. Sometimes data should be same in source and target tables, but sometimes data may not be the same. Okay, because we need to apply certain rules the data on the fly. So that's the reason we need to also compare the data and the check with respect to requirements. And data with primary key and foreign key check. We need to also verify the data with respect to the primary key and foreign keys. And null check. This is most important. Null and not null check. Suppose I discussed this one in the SQL classes. Null is a constraint. If I define, for example, there is a table. The table column is defined, apply check constraint. So what the check constraint is, the table column should not allow the nulls. That is my condition. That condition I have applied by using check constraint. I have a table with a column. I don't want to insert nulls in the particular column. So for that, I have created a constraint on the column. I'm saying like it should not null. Not null is a constraint. Then we need to verify whenever the data is inserting into that particular tables. or if the data contains the nulls, then the data should be rejected because we applied the check condition there. We should not allow the null values, but still forcefully we are trying to insert the nulls there. It should reject the data, so that will be verified. Null check is also very important. Now data precision check. So here for ETL testing we need to prepare the lot of test data. So for example, data precision means create a test data in the source table with different precisions and ensure the loaded data has precision as per the requirement. So precision and scale, there are two things. So for example, if I have a number, what is precision and scale? Any idea? So I have a source table. This is my source table and this is my target table. Suppose here I have salary column and in the source also I have a salary column. Suppose the salary is like 50.7353. So suppose some decimal number is there. This is basically called precision. This is basically called as a scale. This is basically called as a precision. And the target table also should have the same kind of scale as well as precision. Without after decimal, there are four number of digits are there. So after transmitting the data, here also should be four digits. Sometimes you will find some issues like I have four digits. After transforming the data, last one or two digits will be gone. That basically truncated. Why this happens? Because here I have defined a data type like number 3 comma suppose 5. What is 3 comma 5? 3 defines before decimal how many number of values should be. After decimal how many number of values should be. That is defined by this data type. But in the source I have a 3 and 5. But when you come to the target I have a 3 comma 2. Now what happens here? If I have 5 digits like this, when you transforming to this target, only first I have defined as a 2, right? So first two digits will be taken after decimal. Last three numbers will be truncated. So this should not be having, should not happen, right? So that is also we need to verify. So we need to write few test cases for that. This is basically called as precision check, data precision check, and then date format check. So date is very important field because we can put the date in different formats. Some countries, some people will put date DDYY, DDMMYY format. Some people put first month, then date, then year. So there are n number of formats are there for maintaining the date. For pulling and the loading the data in the source to target system, we need to validate the date formats correctly moving or not. And then all business transformation rules. These are very important. This is a core, right? So from the mapping document, we need to get these transformations. So what kind of transformation rules have been defined? So based on the transformation rules, we need to prepare our test cases, and also here a lot of SQL commands we require. Here the SQL commands will be prepared as part of test data. So SQL itself is a test data here. Okay, so if you want to verify the transformations, we must create our SQL commands. That is up to you as a tester's jobs. Developer will also create those commands because they will use some tools for transforming, right? One source to target command. If they want to move the data from the source to target, they have to create few commands. They have to write some queries, right? And they have to enforce the transformation rules in those queries. Similarly, as a tester, we need to refer the mapping document, and also we need to prepare our own queries for testing the data between the source and target. That is our job. So every transformation mentioned in the document TSD, it is not TST, transformation specification document, okay, needs to be tested. Keep separate test cases for every transformation. So here the transformations are very important. We are going to discuss what is transformation, what are the different types of transformations are available. Then we will also implement this transformation. We will write so many queries and we will test them. Okay. So these are all the different areas we need to verify as part of ETL testing. So what are they? Again, let me repeat once again high level. Table structure, constraint check, index check, source data validation, data count check, and data comparison check, duplicate data validation, and data with the primary key and foreign key checks, null checks, data precision check, date format, and then all business transformation rules. So these are high level scenarios. Okay, in detail we will discuss again each and every scenario having multiple test cases again. So basically these are the high level ETL test scenarios which we are going to focus on. Okay, so now let us move on to the actual concept, that is transformations. We need to understand what is transformation, what are all types of transformations. Then let us see few examples. We will write our own transformation by using SQL commands. Okay, fine, so far clear everyone? Kavita and Sandeep? Right, so now let us move on. Transformation. This is very important. If you go for an interview, you will get lot many questions on this. Okay. So basically, what is transformation? That we need to understand. Then we go for the types and how we need to implement transformation, how to write the queries. We will see them so far later. First of all, let us understand what is transformation. The name itself says transformation. Transformation means change one stage to another stage, that is transformation, right? So here in the source table I have a column, I have few rows and columns. In the target table also I have a few columns and rows. Transformation means, for example, in the source table I have a salary column, I have a salary column, and I have a bonus column. There are two columns in the source table. But in the target table, I have only one column as per the data model or requirement, that is total salary column. Now I want to move this data from the source to target data. Now here I have a rule. What is this rule? Whenever I want to move this data from these two columns into one single column, I want to add these two columns. Like suppose there is a one record, salary is 50,000, the bonus is suppose 5,000. These are the records. Now whenever we want to move from the source to target, the rule is we need to add salary plus bonus and then result value should be inserted into the total salary. Yes, source means it is the staging. Okay, source means it is the staging. Okay, so here what is the role? In the source table I have a two columns. In the target table we have only one column. But how we need to how we need to load this data? As per the transformation rule, we need to add these two values and the total value we need to insert into the target table. That is the transformation rule. So for this, the developer will implement the SQL query. So if he executed this SQL query, what happens is automatically the data will be moved to the target database with respect to this transformation applied. Okay, so this is the job done by the ETL developer. Now what ETL tester will do? So these transformation rules are available under ETL mapping document. So if they want to move from this column to another column, what is the rule they have mentioned? We need to read this particular rule and we have to write our own SQL query. We have to write our own SQL query. So after writing the SQL query, right? So we need to execute that particular query. So our query is little bit different. Our query is basically validating the data, right? So here we have 10 records. After moving here also we have 10 records. First of all, we need to check the data count is correct or not. Then for every record after adding this, we will get this total value, right? This total value correct or not, that we need to verify. So for this, we need to write our own query for validating the data. That is ETL tester job. So ETL script is implemented by developer, and after ETL script is executed, the source and target data will be validated by the ETL tester. So the transformation is nothing but a rule which we need to apply when the data is loading from the source to target. That is basically called as transformation. Okay. Now let us see types of transformations. What are all transformations available? So basically we have n number of transformations. Uh, there are all kinds of transformations are divided into two categories based on their behavior. Okay, I'll tell you what is the difference between these two. First of all, active transformation. Active transformation means the output record count of the transformation may or may not equal to the input record count. For example, in the source table, I have 10 records. I have 10 records. After loading the data in the target table, maybe I have only 5 records. Okay, the data is changed, the count is different, but how the count is different? Maybe there is a rule, transformation rule. After applying that rule, there are only 10 records. Okay, for example, assume that in the source table, I have 10 members, 10 employees are there in the source table. In the target table, as per the rule or as per the transformation, I should have only the employees whose salary is greater than 30,000. That is my transformation rule. But now in the source table, I have 10 records. But maybe some employees' salaries are less than 30,000, right? So those records will not update in the target table. So in that case, maybe the target table contains few records. So their count will not be matched. So those kind of transaction or transformations are called as active transformation. Sometimes may or may not equal. That is basically called as active transformation. I have given one example here. When we apply filter transformation for age column with the condition of age between 25 and 40, in this case, the data will come out which satisfies this condition. Hence, the outcome count cannot be predicted. So just now I have said you one example with a salary. The same example I have explained. Here I have taken an age column. In the source table, there are n number of ages. But in the target table, I want records only between 25 to 40 age. So here we have filtered the records. That's the reason this transformation is called as filter transformation. Filter transformation in the sense we have filtered the records based upon the age limit. Based upon the age limit, we filter those records. That's the reason this transformation is called as a filter transformation. Okay, we will see a few more examples. So this is one of the example of active transformation because there may or may not equal number of records present in the source and target. That is basically called as active transformation. But what is passive transformation? Passive transformation means the output record count of the transformation is equal to the input record count. In the source table and the target table, the number of records should be exactly the same. Number of records, not records. Number of records should be same. That is a passive transformation. Okay. For example, here I have given one example. Let us say when we apply expression transformation to concatenate first name and the last name columns, in this the data will come out even though the columns do not have values. See now, this is one more example. For this is basically expression transformation. What is expression transformation? Let me give you one example here. I have in the source table, as I said, number of records should be same in the passive transaction, right? Passive transformation. So here I have source table having two columns, first name and the last name. First name, last name. This is the source table. Now I have a target table which contains only one column. That column name is name. Now when I want to load this data source to target, I want to add these two things, first name plus last name. For example, here Ravi is there and here the Kumar is there. In the target table I want Ravi Kumar. This is my name. So here if I want to load the data like this in this format, I need to concatenate first name and the last name, and then I need to put together. So here I am doing the plus, means concatenation Ravi plus Kumar. This is basically a expression. In mathematical language we call as this is expression. So basically this is basically called as expression transformation. So we are applying some expression so that it is called as expression transformation. Now in this case I have 10 records now. So if I apply this expression transformation, the target table should also contain the 10 records. There is no way to filter those records, right? It is just adding the first name and the last name and storing the full name in the target table. That is my requirement. But in this expression or in this transformation, there is no chance to eliminate the records. If we have 10 records, we must have 10 records in the target table. So this is another example of passive transaction. So active transaction, in active transaction, number of records should not be the same. But in passive transformation, the number of records should be the same. That's depend on what kind of transformation we applied. Okay, passive transformation and active transformation with examples. Now let us understand what different examples of active transformation and passive transformation. So types of transformation. So these are the basic most important transformations we have. Filter transformation, expression transformation, aggregator transformation, joiner transformation, union transformation, sorter transformation, and rank transformation. So in these transformations, few of them are belongs to active transformations and few of them comes under the passive transformation. Okay, so what is the difference between again those two? Active transformation means the number of records may or may not same, but in passive transformation the number of records or count should be the same. Here these are the different types of transactions. Filter transformation, sorry, these are transformation, not transaction. Okay, expression transformation, aggregator, joiner, union, sorter, and rank. So if you want to understand this transformation, we should have good familiar with queries and joins in SQL part. Okay, now let us discuss all these kind of transformations with some examples. First of all, filter transformation. Filter transformation. So it is an active transformation. Why we are calling active transformation? Because we are filtering the records. So source and target table may not, the records, number of records are equal. So it is an active transformation. A column can be selected as a filter with a condition. The data will be returned if it satisfies the filter condition, else the data will be rejected. So for example, if I write a query like this, select star from employees table where department ID equal to 10. So this query, suppose the table is having 100 records, but this query will filter the records based upon the department number or department ID. So if I execute this query, this will give you only few number of records which the condition is satisfied, like department ID is equal to 10. So whichever record is satisfied this condition, only those records will be filtered. That's the reason this is called as a filter transformation. If we want to write a query for filter transformation, this is how we need to write the query. If we apply some filter condition, then that is a filter transformation. If we have a query with a where class with some condition, that is called as a filter transformation. Filter transformation. Next one is expression transformation. Expression transformation means it's a passive transformation. So just now we have seen expression means if I apply some calculation On the columns, the number of records will not be changed. The number of records should be same in the source as well as target. So it's a passive transformation. An expression can be mentioned like concatenation or replacement for a null values. The expression will be applied to a specific column and return. See now this query, select first name, salary plus 1000, and I have used column alias, that is total salary from employees. But actual the table contains only the first name and salary column. The table contains first name and the salary column, but another column I am writing here, salary plus 1000. So what this will return? It will have it. Suppose the table is having 10 records. This query also written 10 records, but additionally it will add one more column, that is salary plus 1000, that is total salary. So we are applying some expression on a column here. That is the reason this is called as expression transformation. Expression means some kind of calculation applying on the column. This will not affect number of records in a table. That's the reason we are called this as a expression transformation. Expression transformation. We are applying certain condition, or we are applying not condition. Expression is different than condition. Here the department ID is equal to 10. This is a condition. If I put some condition, automatically the records will be filtered. But when I apply the expression, the records will not be filtered, but the column will be displayed with the same number of records in the source as well as target tables. That is expression transformation. Expression transformation. Next, aggregator transformation. Aggregator transformation. Aggregator means the query should be executed on multiple groups. We have seen aggregate functions, group functions, we have aggregate functions we discussed, right? So all average, minimum, maximum, these functions are called aggregate functions, group functions. So if I use these kind of functions in a query, that is basically called as aggregator transformation. So let us see example here. This is also an active transformation because minimum salary, maximum salary, and also we are applying the group by. Group by itself is a condition. So whenever the condition comes into the picture, that becomes an active transformation because the number of records will be vary. The count of number of records will be vary. It's not be the same. That's the reason it is an active transformation. So an aggregate function can be applied to the measure such as max, average, or count and minimum. These are the different methods we can apply on the grouping columns. If I apply these methods on the grouping columns, automatically the data will be filtered. But we are applying the group functions or aggregator functions, so that this is called as a aggregator transformations. Aggregator transformations. Okay, let us see one example for aggregator transformation. So let us see, I have a table here, same, this is my table, this is my source table. So in this table I have department ID, right, and salary column. There are department ID and the salary column. So for example, department 10, 20, again 10, 20, 20, 10, 20. So there are duplicate department IDs are there. In the salary column, we have multiple salaries. Okay, this is my table. Now in the target table, what I want to get is, I have a column in the target table. Here I want to display the department ID. That is the first column. And the second column should be average of salaries of each department. So for example, if I take 10, so this is one salary of department number 10, and here one more department, this is 10, this is 10, and whatever salaries are there in the same department, I want to count the average of those salaries, and then I want to put here. So here I want to put average of salary. So again here maximum of salary. This is another, sorry, this is another column. Just a moment. So in the target table, I have max of salary and minimum of salary. So these are the different columns I have. Now, based on this data, I need to write a query. This query will pull the records, data, and insert into the target table. How it is possible? We need to apply the aggregator methods on this particular data. So if you write query like that, that is basically becomes a aggregator transformation. This is an example. See now, select department ID, minimum of salary, maximum salary from employees, group by department ID. So this is a query which is example for aggregator transformation. Aggregator transformation. Now the joiner transformation. Joiner, the name itself says joining of two or more tables. Joining of two or more tables. Sometimes in the source side we have two tables, but the target side we have only one table. So we need to combine the data from the two tables and put together in one table. So there we need to apply the join. So whenever the join comes into the picture in a query, that is basically called as a joiner transformation. So here there is an example. It is basically active transformation again, because after joining the data there may not be equal, count will be equal, so the count will be different because we are joining the data from the two tables and putting together in one table. The data may not be the same, so that's the reason it is called as active transformation. So here we need to join two or more sources or more tables along with the join condition. Join itself is a condition, right? Whenever the condition comes into the picture, count will be different. From source to target, the count will be different because we apply the condition. So the data will be returned if it satisfies the join condition, else data will be rejected. See now here I have first name, comma department name from employees department. So here I have used two tables, employees and departments. I am getting the first name from employees table and department name from the department tables. And if this condition is met, right? So whatever the output we are getting from this query, we can we can load the data into the target table. So in that case, source and target data may not be equal. So this query is an example of joiner transformation. Joiner transformation. This is active transformation. And the other one is union transformation. Union, it is also a kind of a join, right? Join is advanced than union. So because what is the difference between join and union? I told you this in SQL classes, right? What is the difference between union and join? Unions, union all, union, intersect, minus, these are all union set operators, right? So these operators can be used if the same data type, the column from the multiple tables should be the same data type. Then only we can go for unions or set operators. But the join can be used even though if you have multiple data types in the multiple tables. Right? So here union means the transformation name itself is a union transformation because we need to apply some union here. So here this is an example. The two or more sources can be merged with this transformation. Here we are merging this. Union means we are merging this. Joiner is not merging. See the difference between this one and this one. In the joiner transaction, we are not merging the records. Even though we have two tables, we are getting the few records from first table, few records from the second table, and we are populating those two records and those two columns in the target table based on certain condition. But in union, what we need to do is we need to two or more sources can be merged with the transaction. See the query here. Select employee ID, job ID, department ID from employees. This is one table. And union, select employee ID, job ID, department ID from job history. This is a different table. This is another table. But even though both tables are different, we are merging the data by using union operator. It will eliminate the duplicate records. We will get all the records from the first table and the second table, but duplicate records will be eliminated. That is the union operator. So this is basically called as union transformation. If I use union operator in the query, that is basically called as union operators. So when I join or when I merge these two tables. Suppose there is a one table contains, source table contains 10 records, a target table contains 20 records. If I merge them, I may have 30 records. Sometimes if there is any duplicates, I may have same records. There is a chance, right? So this is basically comes under active transformation. Aggregator, joiner and union. Sorry, this is active transformation. Union is comes under the active transformation. Now, sorter transformation. Sorter. Sorter means how we need to sort the records using order by class. So for example, in the source table, very simple. If I use order by class, that becomes a sorter transformation. I have a source table here. I have a target table here. But in the source table, the records are not in the based on order. For example, here 101, 105, 102, 100. So this is not in order, but names are there. So this is ID and this is a name. Now come to the target table. I want to store the same number of records. I want to store the same number of records, but I need to maintain the order, right? So in the query, how we need to pull these records and order, select ID and the name from this table, order by ID. So we will get the same number of records, but the order will be ascending order or descending order, right? So this is basically called as sorter transformation. We are sorting the data from source to table. When we move to the source to target, we are moving the data. So what kind of transaction it should be? It should be, the data count should be the same here, right? So this should be passive transaction. We cannot say it should be passive transaction. We cannot say it is a passive transactions because order by salary, DSCC I'm saying, right? Order by salary. Select star from employees, order by salary. Even though the number of records are same, arrangement of data will be the different. So if we will need to consider this point also, not only number of records, we need to also consider this point. The data from the source table and the target table, exactly same or not. If exactly the same, then we can say it is a passive. This is a generic meaning, passive and active. Active means it is keep on changing. Passive means it is a standard or static. So if I apply the order by class, is there any change in the data? No, right? The same 10 records will be appeared in the second table, but there is a change actually. So what is the change? Order by. Suppose in the source table we have 1, 5, 10, 2, 7 in the random order, but in the target table we have a order 1, 2, 3, 4. There is a change. So in that context, we can say this is a active transformation. But some people also say this is a passive transformation in another aspect. Combined, we can say it may active transformation and also it can fall into passive transformation based on the output we are getting. Okay. And then finally rank transformation. This is very important. Rank. First of all, we need to understand what is a rank. Okay. I'll give you one example. What is rank? Then we go for rank transaction. Okay. Now I have a student table. Let us see. Please hold on. I will finish another 10 minutes. Okay. So now I have a table. I have a student marks table. So for example, here student name or student number. I have a marks column. Okay. And I have a student number 1, 2, 3, 4 and so on. The first student getting marks as 50, second student 100, third student 50 again, fourth student 60, fifth student again 100, sixth student again getting some 70. Okay, this is my records. This is the first record, second record, third, fourth and fifth record, and this is the sixth record. Now if you want to assign a rank to the students, if I give some rank to the students, the first rank, for whose we need to give the first rank? Student number 1, 2, 3, 4, 5 or 6. Who is the first? Who is getting the first rank in this list? Who is getting the first rank? Whoever is getting the highest marks, that student getting the highest rank, right? The first rank will goes to 100 is the highest one, but there are two people who are getting the 100. There are two people, they are getting the 100 marks. So first rank will go to second and fifth students. Similarly, the second rank will go to first and third student. First and third student. Now the third rank, 50, after 150 there is a 60 and 70 also, right? So the third rank is goes to sixth student, and finally fourth rank will goes to fourth student. So this is how we need to assign the ranks. Now in the target table, I want to get student ID and the rank. This is what I need, this data. Student ID and the rank, both are required. So if I write this transformation, how we need to store this? Student ID 1. What is the rank of student 1? 50, right? 50 comes under the second rank. He is getting the second rank. So rank is 2. Now student is 2 now. So for him this is the first rank. So student number 2 is getting the first rank 1. Student number 3, he is also getting the 50. 50 means which will fall under third rank. So second rank. 50 is getting the third rank. And the fourth student is getting 60 marks. So fourth student is getting the fourth rank, right? The fourth student is getting the fourth rank. Now fifth student is getting the 100. And which rank? And the first rank. So now if you come here, fifth student is getting the first rank. If you observe these records, first rank is coming for the first rank is assigned to the two students, but the two records are displayed here. Two records are displayed here, even though the first rank is assigned, first rank is getting by the two people, right? So two are displayed here. This is basically called as a ranking. How we need to get these values? By using rank function. In database, Oracle database, there is a two functions to get the rank. One is rank function, the other one is dense underscore rank. These are the two methods we have. Rank, dense underscore rank. We need to understand the difference between these two. Select first name, salary, rank over, we need to specify in which column we need to count the rank. So order by salary, and we need to assign the salary column in particular order. Then only it will get the rank, right? Otherwise, it will suppose the salary column is in random numbers, we cannot get the rank. So if I want to get the rank, the column values must be in particular order. So that's the reason here I am saying rank over order by salary. This is all one statement. Remember this. This is all one statement. This will give you the rank of this particular salary from employees. This is the alias name. Rank is a column alias from employees. This will give the rank. Now what is this one? First name, salary, dense underscore rank over order by salary. The query is exactly the same, but the method is different. Dense underscore rank. Let us see the output, then you will see the difference. Let us see this, just a moment. Rank and dense rank. Now we have understood what is rank, right? So see this example. Difference between the rank, dense rank, and there is another method called row underscore number. Row number is also there. It will give you basically the row number or row ID. Okay. So the first query is select first name, salary, rank over order by salary. Rank is an alias name from employees. This is the first query. And the second query is select first name, salary, dense underscore rank over order by salary, rank from employees. This is the same query, but I have used dense underscore rank. And the same query, instead of dense underscore rank, I have used row underscore number. This is another method we have. And what is the difference between these three methods? So let us write one query, and in this query I will use all three methods, and then you can see the difference. I'll print all these values in multiple columns. Select first name salary, rank over order by salary rank, comma, dense rank over order by salary dense rank, comma, row number over order by salary row number from employees. If I execute this particular query, what this will display? This is an output. Let us see this. Here this is ID, name, department and the salary. So I have applied the rank on salary column, right? So observe this rank, dense rank and the row number. If you apply the rank, see here this is a employee ID. So if you observe this 001, salary is highest here. 1, 2, 3, 4, 5, 6 digits are there. This means 19 something, right? If you see other salaries, here the rank is 1, this is 2, this is 3, 3. Why it is 3 here? Because here the salaries are same. So these two employees comes under one rank, right? Suppose in a class both students are getting the same number of marks, those two people getting the same rank, right, based upon the marks. So similarly here these two employees are getting the same salary, so that we have to apply the same rank to these two employees. And similar, this is the fifth rank, the continuation, fourth will not be there. See now, 1, 2, 3, but fourth should come here, but fourth will not be there because the same rank is assigned to the two employees. It will continue with the next number, so 4 will be skipped. So 5, 6, 7, 8. See now here again the 8, 8, but there is no 9. Actually this 20,000, right, here the 9 should be there, but these two people are getting the same rank, so there is no 9 at all, so directly jump into the 10. This is basically the rank output. But when you come to the dense rank, the difference between these two are small difference, you need to observe very carefully. So here these two people are getting the same rank, so T3, 3, 3, that is fine. But the next guy who is getting the next salary, for that employee it is assigning as a fourth rank. But in the rank function it is jumped into the next value, it is skipped 4. But in the dense rank it will give you 4, 5, 6 and 7 is assigned to the two people, and the next one should be jump into the 10 here. 9 is skipped, but here it should be 8. After 7 there is 8. 8 is assigned to the 10,000. So that is basically the difference between rank and dense rank. So here I have taken as dummy outputs. Okay, don't consider these salaries in order or not order, but the rank and dense rank and row number. Just consider only these three columns. So the difference between rank and dense rank is, in the rank function, if any two of them are getting the same rank, the next rank should be jumped into the next number. So 4 will be skipped here, and here the 9 will be skipped. But here these two employees getting the same rank, what's the next number? Fourth will be continued, 4, 5, 6, 7, and 7 is assigned to these two employees, and next number is 8. 8 will be continued. So this is the difference between rank and dense rank. Then what is the row number? Row number is a normal. So 1, 2, 3, 4, 5. It will not consider at all the rank and all. Just it will give you a number to the particular row. That's it. So it is normally in ascending order. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is the row number. Okay. So rank, dense rank and the row number. If you want to get these values, we have to use these methods. Rank, dense underscore rank, row underscore number. If I use these methods, we will get these values. Got my point? Fine. So this is how we need to execute this rank function. So let me execute this query and show you in the Oracle database. Just a moment, because this is very important. So I have connected to the HR database. And now I'm executing this particular query. Execute this. See now here, this is rank column, dense rank column, and this is the row number column. If you observe the rank column, observe very carefully. This is 1. Second rank is came for 2 employees and 3 is skipped. Next continue with the 4. 4 is come for 2 employees because both the salaries are same. So it will jump into the 6th one. 5th is eliminated. And 6th rank is came for multiple employees. Here all are 2500. So 6th ranks assigned to the multiple employees. And here how many values are 6 are there? 1, 2, 3, 4, 5, 6 are there. So after the 6, there are 6 numbers will be gone. Directly jump into the 12. Got the difference here? So here 6 is assigned to how many? 1, 2, 3, 4, 5, 6. So 1, 6 is fine. Rest of the numbers 1, 2, 3, 4. So after 6, there are 6 numbers will be skipped. And what is the next number came? And 12 came. Now 12 is assigned to how many? 1, 2, 3, 4. 4 people are having the 12 rank. And after 12, how many numbers should be skipped? 13, 14, 15. Right? So this 12 should be there. But 1, 2, 3 12s are originally came. So 13, 14, 15 will be skipped. And then 16 will come into the picture. And after that 16 is assigned to the 2. And what is the next number? 17. So only 16 is extra. So 17 is skipped. Then 18 will start. So this is how rank will applied. When you come to the dense rank, so first is fine. So second ranks are applied for 2 employees, and then here the value will not skip. Then it will start with the next number 3, 4, 5, 6, 7, 8. The no number is skipped from here. Every number will continue. This is dense rank. When you come to the row number, it is normal in order 1, 2, 3, 4, 5, 6, 7. It will not consider the rank or dense rank. Okay, so this is the kind of important query. This is basically uh, rank transaction, rank transformation. So we need to write these kind of queries when you write your test cases. Is it clear, both of you, how we need to get the rank, dense rank, and row number? So if I apply these methods in this query, that's basically called as rank transformation. Rank transformation. Okay. Now I'll stop for today here. So far what we discussed is what is ETL testing, what are the different stages we have, and what is the process of ETL testing, and what are the ETL testing scenarios which we need to test. And then we have seen what is transformation, what are the different types of transformations. And the next session we will see the exact document. What is ETL mapping document? What is a data model? What it contains? And I'll show you those documents. And also I will show you how to write test cases based on those documentation. Okay. Any questions so far, anyone? So I'll stop for today here. Let's move on to the tomorrow session.